Here, discuss about the Newton's law of motions. Newton's law of motions here. First law is an object is a motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by unbalanced forces. Here next second law of Newton's second law is force equals mass times acceleration. It means force is directly proportional to the acceleration of the object. And third one is Newton's third law is for every action there is an equal and opposite reaction. So here let us discuss about the first law, Newton's first law. Here an object is rest to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced forces. Here, what does this means? Basically, an object will keep doing what it was doing unless acted upon by an unbalanced forces. Here, if the object is sitting still, it will remain stationary. If it is was moving at a constant velocity, it will keep moving. It takes force to change a motion of an object. Here, what is a force? Force is a push or pull upon a object resulting from the interaction with another object. Either it is a force is a balanced force or unbalanced force. What is meant by unbalanced force and balanced forces? Here, take one uh, objective. If the force on a object are equal and opposite direction, they are said to be balanced. Here, this is the objective. The acting table pushes the upward on the book, and gravity pulls downward on the book. If equals the gravity equal to the push force, so there is a balanced force. Or otherwise, if not equal, these two are not equal. This is called unbalanced forces. Here, the object experience no change in motion. Here, in balanced forces, if they are not equal and opposite, the forces are unbalanced, and the motion of the object changes. And some example from real life are a soccer ball is sitting at rest. This one is sitting on rest. It takes an unbalanced force of kicking to change its motion. And for example, two teams are playing tug of war. They are both exerting equal force on the rope in opposite direction. This balanced force results in no change in motion. And Newton's first law is also called as the law of inertia. Here, what is meant by inertia? Here, the tendency of objective to resist the change in its state of motion called inertia. Here, first law states that all objects have some inertia. The more mass an object has, the more inertia it it has, and harder it is to change its motion. Where you hear some image there, animation. If you are traveling 70 mph and the car suddenly stops, your body will also traveling 70 mega uh, mph. Here it is animation. And then there are also some truck traveling some distance, some force, I mean speed. It's suddenly stop. The container pushes to the driver seat. So more examples from the real life. Here are some examples. So locomotive, it is a powerful locomotive begins to pull a long line of boxcars that were sitting at a rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a large force to change their motion. Once they are moving, it takes a large force to stop them. Here a second example is there. On our way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia and exerted a very small force on your car. So small that you don't even feel it. And if object motion tend to stay in motion, why don't moving object keep moving forever? Here some of the examples are there. Things don't keep moving forever because there is almost always an unbalanced forces acting on up it. You take one book, a book sliding across the table slows down and stops because of the force of friction. If throw a ball upwards, it is still eventually slow down and fall because of the force of gravity. And the air force in outer space, away from the gravity and any source of friction, a rocket ship launched with a certain speed and direction would keep going in that same direction and the same speed forever. And coming to the second law, Newton's second law, the air force is equal to the mass times acceleration. Here F equal to ma. Here acceleration, what is acceleration? Is a measurement of how quickly an object is changing speed. Here, next one is the what does F equal to ma says. So F equal to ma basically means that the force of an object comes from its mass and its acceleration. Something very massive that changing speed very slowly like a glacier can still have great force. Here, take example of bullet, something very small that changing speed very quickly like a bullet can still have a great force. Something very small changing speed very slowly will have very weak force. So now coming to the next one, Newton's third law. Here, for every action, there is a equal and opposite direction is there in any in inverse. What does this mean? So for every reaction, every force acting on a object, there is equal force acting in the opposite direction. Right now, gravity is pulling you down in our seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. There is a balanced force acting on you, gravity pulling down, your seat pushing up. And this is one. And thinking about these two, what happens if you are standing on a skateboard or slippery floor and push against a wall? You slide in the opposite direction away from the wall because you pushed down the wall, but the wall pushed back on you with equal and opposite force. And next one is why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe. These are the examples of Newton's third law. Here, first on a simple problem, an object is there acting in the direction right side horizontal force 75 newtons and left side horizontal force that one is right side 300, left side 75. So, what is the net force acting on the particular objective? Here, applying this one net force is bigger one minus smaller one 300 minus 75 will be the your net force. Okay. That is 225 newtons is the net force for the particular problem. Then coming to the next one, what is the force necessary for a 1.6 into 10 power 3 kg car to accelerate forward at 2 meter per second? Here applying a second law, Newton's second law, force equal to ma and m is the mass and a is the acceleration. Here the values are there and 1.6 into 10 power 3 kg. A value is 2 meter per second. The substitute these two values in the particular force equal to ma. Force equal to ma. That one is the force is 3 into 10 cube newtons. Okay. Thank you.